We live We live on the Goldilocks planet, right? Just at the right distance from the sun, between Hades, hot Venus, and frigid Mars, and just big enough to be able to retain liquid water, but small enough so that gravity doesn't crush us or attract too many comets like poor Jupiter. And with a gravity so well tuned that it allows water to rise up through evapotranspiration as vapor to form clouds and still cycle down upon us as snow and rainfall. The water flowing down our slopes washes out minerals, biologically active metals, that were pushed up into the mountain ranges by plate tectonics, and brings them into deposits on land and sea, where they can make their way back to the bottom of the gravity well, or be assimilated into the ecosystem and into living cells. Copper, iron, manganese, and zinc permitting plants to photosynthesize and acting as catalysts for cell reproduction. Divalent magnesium and calcium regulating cell metabolism. Iron creating the oxygen-loving hemoglobin in our red blood. Metallothioneins, or special bioactive metal ions, creating important proteins. The metal calcium working with the metalloid silicon and the non-metal phosphorus creating our bones. Metals are us. Our Earth's core is primarily made out of metal, iron and nickel, along with small amounts of other dense elements like the heavy metals gold, platinum, lead, and uranium. Quote, above the core, Caltech's website tells us, is Earth's mantle, which is made up of rock containing silicon, iron, magnesium, aluminum, oxygen, and other minerals. The rocky surface layer of Earth, called the crust, is made up mostly of oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium, end quote. We live on a heavy metal planet, covered with light rock, made up of metal bands and metalloid non-metal streaks. And this creates the jazz of life, no matter what kind of music you're into. But here's the rub. Like with anything, the amount of metal that gets into you, in what form and concentration and over what time period, determines whether it's healthy or toxic. When the mob tells you to eat lead, they aren't offering you anything healthy. Lead in the form of bullets or buckshot, or paint chips or gasoline spills in the water is always toxic. Gold and silver, however, can safely be put into fillings and in the body, while the use of colloidal silver used as a tonic to increase health is seen as deeply controversial within the scientific community, and they actually call it dangerous quackery. Metals can be mixed together with each other and other materials into alloys with tremendous new properties, like the way carbon and iron are combined to form surgically safe and cooking safe stainless steel scalpels, knives, and forks, and cooking pots. And when we're done using metals in our consumer goods, one thing about them stands out. They have the incredible property of being easy to recycle. They're easy to melt and isolate. Many are magnetic and all conduct electricity. And so they can all be recycled cost effectively. Metals are so valuable, in fact, that there's no good economic reason not to recycle them. If metals that were used in human consumer goods are still contaminating the earth, or are going into landfills or into streams, rivers, and oceans, then there's something wrong. And there is something wrong in much of the world. Here's a picture of me standing knee-deep in a garbage dump in the Himalayas in Nepal. These are all beer cans and soda cans hand-carried from the last airfield in Lukla by Sherpas for the tourists on the Tea Lodge Trail to Mount Everest. The tourists drink what's in them and then toss them. And even though there are aluminum can recycling facilities down in Kathmandu, it apparently isn't worth anybody's while to hand carry them all the way down back to Lukla and put them on an airplane or truck. This is a question of economics and politics again. While aluminum is valuable, it hasn't been priced high enough to create an incentive to reclaim it from the high Himalayas and other places where labor isn't cheap enough to transport it. Those pesky transaction costs. My suggestion, of course, was to do much recycling and reuse of waste locally. My suggestion is always, of course, to do as much recycling and reuse of waste locally. And my solution for the metal cans of Mount Everest was a little unorthodox. Knowing just enough about electrochemistry to be mildly dangerous, I started taking the cans and dissolving a few of them into aluminum oxide powder and hydrogen gas using potash from the Sherpa fires. The hydrogen I used to burn and to generate enough of an electric current to run my flashlight at night. I guess I invented what I called the Culhane aluminum can tab torch, finding that I could power 5 super bright LED lights for several hours off a single Coke can tab. It also works with discarded zinc nails. And it isn't an unknown phenomenon that I discovered, just a weird application of a well-known principle. The Nazis used scrap and waste aluminum with lye to make hydrogen for their Zeppelins, and aluminum air batteries have been known and used for over a century. Metals don't always have to be recycled to make them useful. There are even people who are using waste metals as fuels to run engines. Yes, there are ways to, quote, directly combust recyclable metal fuels for zero carbon heat and power, end quote, with experts now saying that, quote, metals are promising high energy density, low emission recyclable energy carriers, end quote. But once again, most non-scientists and engineers don't know all the amazing things that can be done with the metals that we carelessly throw away. In this module, you get to test your metal as a sustainability pioneer by exploring the amazing world of metals. Heck, you'll find that as the song goes, even rust never sleeps. It's up to your generation to figure out how best to use it.